Hey guys, we're looking here at Unit 1, question number 3, 4, 5, and 6. So looking at question number 3, we have the Unit 1 economic hockey stick that we had studied back at the beginning of the semester, is measuring the growth rate as growth being the change in income, right? When we're looking at the GDP of countries, right? We're looking at the per capita and the general GDP and seeing how countries have grown. And we're looking at the change in income, right, divided by the original level of income. So now if we're going to be looking at the growth rate of COVID-19, right, let's say we want to know how quick is it growing maybe in one country or another so we can do a comparison. How would we be writing that formula? Okay, so it'd be the COVID-19 growth rate would be the change in what over the original level of what? Okay, so you guys get to fill that in yourself. That's going to be part of this assignment. And the hint is to go back and look at Unit 1 and just think about what we were measuring there and now what we are measuring here. And that's going to be what the answer is, that change. Okay, so what do you think it is? You are correct, COVID-19. So you would write that down. So number 4, we're looking at exponential growth. Okay, so the COVID-19 contagion, I'm just going to correct the spelling. So it's COVID without the R. That contagion grows exponentially, which means it can double in size after a period of time. And as each person contaminates more than one during the course of their illness. So that's what's going to help it to be able to increase its how fast it's growing is going to be how quickly that person is contaminating other people, right? How quickly it's spreading. So here we have our formula. G is our daily growth rate. N is the number of cases in a particular time. T is the time. So it's N times the quantity of 1 plus G to the T. Okay, and that's how many cases after how many T days. Okay, and if G is the square root of 2, or 4.42, 1 plus G squared is 2. Okay, so according to these numbers, cases will double every 2 days. So let's see what that looks like. We're going to apply some math to our understanding of economics. Okay, so here we have the European Center for Disease Prevention and Control on April 1st saying that there were 41,887 COVID-19 cases worldwide, and that the cases were doubling every 7 days, so once a week. We have 2 data sets here. We can click on this to take a look at what it is that they're talking about. Okay, and when we click on the New York Times data set, we come here. We need to click on this, okay, to be able to open up the article. And then we can scroll down and see the data. And here we're looking at how many cases are doubling. Oh, here we have deaths, okay? So how many places have at least 25 deaths? Okay, of all the places that have at least 25 deaths, how many of them are doubling every day, every 2 days, every 3 days, okay, every week, all right? And that's what we're looking at, that doubling of every week. So here Iran is on that level. The U.S. hasn't gotten there yet. We're still doubling I think we're getting close to the 5-day line at this point. Okay, so those are COVID-19 deaths. The other set of data I have here is looking at more general numbers. So we have coronavirus disease. If we click on that link, that's going to open us up. And again, we're going to see confirmed deaths, but we're going to see this in a linear equation. In the whole world, how many deaths are there? And we can see we have this data after April 1st. Right, so it continues. Now it's April 22nd. Okay, so we'll be able to continue to see, and then we can look at it from a per country level as well. So let's say I want to compare the United States to the rest of the world. So I can go and take a look at United States, okay, and go and see how we compare to the whole world. And I can continue to add different countries and look at that comparison. So this is our linear model. Each time we have a new death, that adds it to the equation, right? So here we're looking at 42,000 deaths, and there's 169,000 worldwide, okay? What we're doing though is we're looking at something beyond just the linear model. Okay, we're looking at those exponential numbers. So I'm back here to the New York Times, and I'm going to scroll down a little further because the New York Times also has data divided out by states, and part of your homework assignment is to look at a state of your choice and understand what's going on there. So here we have in New York, we have 15,000 deaths, and they're doubling every 2 weeks. Okay, so if I go back to my workbook, let's see how we can start understanding these numbers. Okay, so we have this formula of understanding how many cases we would find as we're looking at this doubling of cases, okay, this exponential number. So our original number of cases was 41,000. So let's say we're an economist and we want to make a prediction. We want to say in a week, there's going to be X number of deaths from coronavirus, looking at the trend continuing exactly how it is right now. And what will be interesting with that is because economists like to do something called forecasting, almost like a weather reporter. We like to talk about what's going to happen so that way businesses and people can be prepared and plan. Because one of the most important things for an economy is to know what's coming next, right? To be able to plan for a foreseeable, predictable future so you're making the right choices and right decisions. So if I'm going to look at today's numbers and say, well, these numbers are going to continue, and predict that in 1 week we will go from 41,887 deaths to 83,754 deaths, then when that new week comes, in this case it was April 7th, I can go back and look and see, was I correct? Okay, and the way I got to that number is important. Okay, so here we're looking at 41,000 times a number of weeks, okay, which is 1, and it's doubling every week. So we have that 1 to the 2. So I do my POMDES, my please excuse my dear Aunt Sally, okay, so parentheses exponentials. So I have my formulas run in the right direction. I come up with 83,754. If I go back to my data, let's see what happens, okay? Here I have, let's go back to my totals, right? So we're looking at total world amounts. So on April 1st, let's go to April 1st. We were at that 41,000. Okay, there it's a little bit more, that 40,904. Okay, so again, if we're going to be looking at that number doubling every week, how many deaths would we expect by April 7th? Let's go take a look. So we're going to do 41,904 times what? It's going to be doubling. You are correct. Times 2. Okay? And that comes out to 83808. So I'm going to cruise up here to April 7th. And I don't have 83,808 deaths. I have less. I have 74,065 deaths. So what does that tell me? I just made a prediction based on current data from April, the beginning of April, saying that deaths were doubling every week. But now after a week, I found my deaths haven't doubled at all. So what is that starting to tell me as an economist about the number of deaths due to COVID-19? Yes, they're less than what we think. So they're not doubling every single week. So that's good news, right? Let's go back to our worksheet, okay? And let's continue to look at more numbers, okay? So let's say we were going to stay with that same number, right? Saying, well, it's going to be doubling every week, okay? So week 1, we're already predicting it's going to be 83,754. Week 2, what is it going to be if it's continuing to still grow at that same rate? So now what we're looking at is 2, right? It's going to be every 2 weeks. So we're going to first solve 2 times 2 is 4, okay? So 2 to the 2 is 4. And what that's going to give us now is 41,877 times 4. So if we run that on our calculator, 41877, or you can do long division, well, not even that long, times 4, Okay, you come up with a number of 167,508 cases. So you get to write that down in your workbook. And let's say this keeps on going for an entire month. Oh my goodness, what kind of losses am I expecting after a month? So again, I would be using that same formula now. Instead of it being 2 weeks, it would be 4 weeks. And 4 to the second is going to be what? What am I going to be timesing my 41,877 by? So 4 to the second is 4 times 4, and that equals, correct. So put that in, run your formula, and see how many cases we have. Okay? Here's a new bonus I've just put in for you guys. Okay? This is not in your workbook, but you're welcome to hand write it in and get some extra credit. Look at this. What happens if the cases tripled? Oh my goodness. Let's say everyone said, I'm done with the social isolation. I am going out there. You know, the day is beautiful. This is it. Live free or die. And unfortunately, we end up doing just that. And now we've just tripled our cases in 1 week. What would my new number look like? So I would do 1 to the third, right? Because it's 1 week and it's tripled. So it's 41,877 times 3. So if I was to run my numbers on that, 41877 times 3, that comes out to 125,631. So 125,631. And in all of these cases, they're cases of death. Okay, I didn't want to write death because that sounds so awful, but that's what we are looking at. Okay, so a very different number, right? If we're tripling our deaths as opposed to only doubling them, right? If we look at this 125 as compared to this 83,000, okay? So that's why when we're looking at this concept of limiting contagion, not having everybody get sick all at once, why that is important. Because when we start looking at things exponentially, we can suddenly have very high numbers very, very quickly. Cool? So it's all about having that balance. So far, so good? The next thing we have is a question: what might cause this rate to change or be different? Okay, so think about what I just told you. Okay, you can look at some of the data, read some news articles. That answer's up to you. And then we have, to measure exponential data, we use a logarithmic scale. Okay, and here's logarithmic growth of COVID-19 over the same time as that linear model. And the question is, how does this look different? Okay, and why is it different, right? What is it showing us that the linear graph is not showing us? Okay, and this time what we're looking at is the total number of cases based on population, right? How many people per how many people in the population are getting identified as having COVID-19. And again, we have to take these numbers with a grain of salt because we know not everybody's getting tested. Okay, but from the data that we have, how is that in relation to the population of the location that's being tested? Okay. Why was Italy's curve flat for so long? Okay, so think about that one, and you get to check your current events to figure out what happened on February 20th in Italy. Okay, so you might want to Google that. That's going to suddenly cause that number to start going up. And pretty much most of the cases on a world level started going up after February 20th. Okay. Number 7 is we saw the difference in looking at linear data, which is the total number of cases, versus logarithmic data, which is the rates of growth. Okay, and we also looked at the exponential data. So what does this experience tell us about measuring and understanding COVID-19 data? Okay, and the hint is to look at slide number 13. That's going to give you some more information in our PowerPoint. All right, well, thank you for sticking with me on these, and I'll let you go on to COVID Unit 2.